A very warm good evening to everyone and welcome to Ashoka University Ask Me Anything. Okay, so please feel free to ask any doubts if you may have from Ashoka University sample papers, and I'll be happy to solve it for you. Please remember, Ashoka University is an examination that is quite heavily influenced by ISI and DSC. Most of the professors are extremely well qualified and from ISI DSC. So the paper and the entrance is very heavily influenced by ISI type and DSC type questions. So in order to prepare for the examination well, it is mandatory that you also do the ISI and the DSC past year question papers, apart from the sample paper of Ashoka. Okay. So today I am giving you an opportunity to ask me anything from the sample paper of Ashoka. I'll be happy to clear out the doubts for you. Right. So I'm already getting a few doubts. All right. Okay. So I have got a doubt for Ashoka University sample question number 2. Okay. Question number 2 को solve करेंगे. Right. The question is in front of you. So there is a traffic light after a right turn on a road. The light can be seen from a car traveling on the road only after it has taken the turn, which is 200 feet away. The cycle of the traffic light is 30 seconds green, followed by 5 seconds yellow, followed by 25 seconds red. Car is traveling at a constant speed of 66 feet per second. If the light is yellow and the driver of the car first sees it, what is the probability that he or she will encounter the red light? So 66 feet per second is the speed of the car. Total distance to be covered is 200 feet. So how many seconds will the car take? It's approximately 3 seconds. So the light stays yellow for 5 seconds only. So the car is able to cross it in the yellow light itself if it sees the yellow light in the first or the second second. Sees it in the first second, crosses the light in the fourth second. Sees it in the second second, crosses the yellow light in the fifth second. Sees it in the third, fourth, or the fifth second, or the cycle of the yellow light, the car will encounter the red, because when it enters in the third second, it will not be able to clear out, because 3 plus 3 is equal to 6. So it will enter the red light. Okay. So 3, 4, and 5 second, if it sees the yellow light, then it will not be able to cross it. It has to stay in the red light for 25 seconds. So what is the probability that she will encounter the red light? It's basically 3 by 5, which is 60%. So it's approximately 60%. I think it's option D here. All right. Okay. What is the cutoff of Ashoka is the next question. The cutoff of Ashoka is about, if you're able to do about 60% of the questions confidently, you should be in with a call. Okay. So 60 to 70% of the questions, if you're able to do properly, you should be in with a call. Other than that, your aim has to do all the 40 questions. There will be 40 questions in the paper, 150 minutes. That's a lot of time, approximately 4 minutes on each question. You should attempt any question. If you are confused between any two options, you should attempt it. You should only leave a question if you're absolutely unsure. Okay. So if you have to guess, then leave the question. If you have to make a calculated guess between two options, please take the calculated guess. Okay. So your aim has to be able to do all 40. Do as much as you can. Okay. Another doubt that is coming in on Zoom. Let me share and let me share the solution for that. Yes, I've got a doubt here. The doubt is the ISIPA Ask Me Anything is already going on. So you should be able to see it there. Okay. So right now a doubt has come for sample paper 2.2 question number 6. So it's this question. The question is on your screen right now. Okay. This is extremely easy. Anyway, I'll share the solution with you. Question number 6, Ashoka sample 1, 2.2. A pregnant woman lives in an area where the Zika virus is fairly rare. 1 in 1,000 people have it. So the probability that she has the virus is positive. What is the probability that she has the virus? So this is what we need to find out. Probability has the so positive given virus into probability that the person has the virus divided by probability that I have a positive reading. So has the virus and I get a positive reading. I get a positive reading with the person having the virus, or I get a positive reading if the person does not have the virus and there is a 5% probability that I get a false positive. Okay, so basically what do I have? I have 99 divided by 99 plus 999 into 5. So 5,4995. So 99 divided by this. 99 divided by 5094. 99 divided by 5094 is approximately how much? It is approximately 2%, right? 99 divided by 5094. You can find out, use the calculator. 0.019, about 2%. So this is okay, right? This is what the answer is. Right. This is what the answer is. Let's take a look at the next doubt that is coming in. Which question, Shruti, please share. Okay. Confidence level, this one. Okay. Let me share with you the answer for this one. Let's see how to do this. Question number 3. Suppose there is a box with 1000 red and black balls. The number of balls for each color separately is not known. You randomly draw one ball from the box 3 times in succession with replacement. Okay. Suppose all the 3 draws are red. Under what level of confidence would you accept the hypothesis that there is an equal number of red and black balls in the box? So the hypothesis is equal number of red and black balls. That is, the probability of a red ball is, say, half. And the alternative is that it is not equal to half. Okay. Now you randomly draw one ball from the box 3 times in succession with replacement, and all the 3 are red. So my estimate is coming out to be 1, where my sample drawn is 3 times. So I can write down my distribution as P naught hat minus the probability as per the null hypothesis divided by P into Q by N. Here the sample is 3. So this is basically half divided by root over 1 by 12. Now, what is this equal to? You can find this out very easily. 1 divided by 12 under root 1 by 2. So this will come out to be 1.73. Okay. Now, if I take a look at a normal distribution, since no distribution is mentioned here and T distribution will require me to have a table. So here, what will I do? I'll basically draw this, and it's a not equal to test, so it will be on both sides. Now, if I have the value 1.73, I will not be rejecting the null hypothesis if the critical region is towards the right, and here it is here. So if 1.73 has to lie in the acceptance region, I know that at 10% level of significance, the value is 1.645. At 5%, the value is 1.96 for a two-tail test. So at 1.96, the critical region lies to the right of 1.73. So under what level of confidence would you accept the hypothesis that there is an equal number of red and black ball? At 5%. Because when it is 1.96, then 1.73 is not lying in the critical region. But if it is 10%, then 1.645 is lying in the critical region. Okay, 1.73 will lie in the critical region if I get a value of 1.645, right? So here the answer is 5%. Question number 6, Ashoka. So this is the answer. Now let's go ahead in the next question. Question number 16 is the next doubt. Let me share with you the solution for question number 16. Then I'll go into that maximum likelihood estimator question. Shruti. देखते हैं, consider two discrete random variables x1 and x2 which are independent and identically distributed. The probability distribution is given as xi is equal to k q to the power k into p. This is like after k failures I get one success. P plus q is equal to 1, k is equal to 0, 1, 2, dot, dot, up to infinity. This is a geometric distribution, okay? What is the conditional probability distribution of x1 given x1 plus x2 is equal to n? So what is x1 is equal to k given x1 plus x2 is equal to n, okay? Now this is what we need to do. So basically x1 is equal to k and x2 is equal to n minus k. This is the numerator, and the denominator is simply x1 plus x2 is equal to n. So the first one is q to the power k into p multiplied by q to the power n minus k multiplied by p divided by x1 plus x2 can be equal to n in various ways. x1 is 0, x2 is n. x1 is 1, x2 is n minus 1. x1 is n, x2 is 0. Right? These are all the approaches. So the numerator is basically q to the power n into p square. Denominator is, if it's 0 and n, this is q to the power 0 into p into q to the power n into p plus q to the power 1 into p into q to the power n minus 1 into p plus dot 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 q to the power n into p into q to the power 0 into p. Okay. Please note, this is qnp square divided by qnp square plus qnp square plus dot 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 qnp square. So each and every probability is the same. I only have to understand how many terms are there in the denominator. How many terms are there in the denominator? It starts with 0, ends with n. So there are n plus 1 terms. Okay. Answer is C. Maximum likelihood. Now let's understand how to find out the MLE. This basic concept will make you understand how to find out the MLE for any sort of a distribution. Okay. So this is an important video. Let me just share this. Estimator. How to find this out. This is an estimate of the population from the sample. Okay. So let's talk about, say, a Poisson distribution. Poisson distribution with the unknown population parameter of lambda. Okay. So I know that for probability x is equal to x, for a Poisson distribution, I have e to the power minus lambda, lambda to the power of x by x factorial. Okay. I know this. Now, given that I have taken out a sample x1, x2, dot, 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 xn, okay, what will be a good estimator of the population parameter lambda? That is what we need to find out. So we know that we have a Poisson distribution. I take out a sample x1, x2 up to xn. Okay. Now I want to estimate the Poisson population parameter lambda. How do I do that? I use a likelihood based on x1 up to xn to find out the parameter lambda. So what do? I keep multiplying each of these. So e to the power minus lambda, lambda to the power of x1 by x1 factorial. This is for x1. For x2, I will again do this. e to the power minus lambda, lambda to the power xn by xn factorial. Okay? So I keep multiplying this. What do I get? E to the power of minus lambda n. I'm adding lambda n times. Okay? Lambda to the power of summation xi going from 1 to n divided by x1 factorial into x2 factorial dot dot xn factorial. So product of xi factorial going from 1 to n. Okay? This is what I write. I am basically multiplying each of these probability and then finding out the maximum likelihood estimator. Maximum likelihood basically means maximizing this in order to find out the estimate for lambda. Okay? So I need to maximize this expression. Now let's take log again. So ln L is basically ln of e to the power minus lambda n plus this is lambda to the power of this. So plus ln lambda to the power of summation xi minus ln product of xi factorial. Okay? This is what we have. Now this can be written as minus lambda n plus summation xi ln lambda minus ln product xi factorial. Okay? Now what am I doing? In order to find out the maximum likelihood estimator, I will differentiate this with respect to the parameter and equate it to 0. So what will I get here? Minus n plus summation xi into 1 by lambda minus 0 is equal to 0. Or in other words, summation xi is equal to n, or 1 by n summation xi is equal to lambda. So the maximum likelihood estimator for lambda is summation xi by n. So the maximum likelihood estimator for lambda is 1 by n summation xi. This is how you find out the maximum likelihood estimator. The same thing you do if you want to do it for a binomial distribution. So a binomial distribution with n and p, and I take x1, x2, dot, 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 xn. So for each of these xi's, I have a probability which I then multiply. So L of, say I want to estimate my p. So then I multiply all ncxi p to the power of xi 1 minus p to the power of n minus xi. So I do it in this way. Okay, then you take the logarithm of this and then you. So I'm sure that you got the idea about how to do this, right? So let's go ahead and solve that MLE question, which a few of you had a doubt with. Okay, so this is Ashoka Sample 2020, Section A, Statistics, question number 3. So what do we have here? We have a random sample of size 8 is to be drawn from a distribution with the probability mass function. This is the probability mass function. Okay, k is equal to 0 or 1. Theta is lying between 0 and 1. Okay, the sample values are 1, 0, 1, 1, 0, 1, 1, 0. Okay, so 8 out of 8, 5 times k is equal to 1 and 3 times k is equal to 0, right? 5 times k is equal to 1, 3 times k is equal to 0. This is what we have. We need to find out the maximum likelihood estimator of theta. So what do we get? 5 times k is equal to 1. So when k is equal to 1, it will be theta to the power 1, 1 minus theta to the power 0. This will happen 5 times. Okay, I am finding out the product in the maximum likelihood function. I need to take the product. So this is what we have for the 5 k's when k is equal to 1. And for 3, I have 1 minus theta to the power 1 minus k is equal to 0. This is happening 3 times. So ultimately, what will I get? I'll get theta to the power 5 into 1 minus theta cube. Okay. Now, in order to find out the maximum likelihood estimator, I need to maximize the maximum likelihood function with respect to the parameter. So I differentiate with respect to the parameter. This is u into v. 5 theta 4 1 minus theta cube plus theta to the power 5 into 3 into 1 minus theta square into minus 1. This has to be equal to 0. For maximum, minima, or a point of inflection, the first order condition has to be equal to 0. I take theta to the power 4 into 1 minus theta square as common. So I get 5 into 1 minus theta minus 3 into theta. Now, this theta to the power 4 into 1 minus theta square is not equal to 0. Therefore, 5 minus 5 theta minus 3 theta is equal to 0. This internal part should be equal to 0 for the first order condition to hold. From here, I get 8 theta is equal to 5, or my theta estimate that I have here is equal to 5 by 8. Mark your answer. So the theta estimate that I have here is 5 by 8. So what did I do? I basically found out the likelihood function. I put in the values according to the sample. Okay. And then I differentiated it in order to find out the maximum value. Okay. So I differentiated it and I found it out. Clear hai? All right. So this is question number 3. Any other question that I can do for you? I'll be happy to do it. Let's check any other doubts that are coming in. All right. Any other doubts that are coming in? Question 7 and 8, sample paper 1. All right. This is Ashoka. Okay, let's take a look at this. Question number 7 and 8. Ashoka sample 2.2, question number 7. X1 up to Xn are independent and identically distributed random variables drawn from a continuous distribution. Let f denote the cumulative distribution function and f be the probability density function of this distribution. So each of the xi have this as the PDF and capital F as the CDF. Consider another random variable y, which is equal to max of x1 to xn. Let g denote the PDF of y. What can be said about g? Chalo, let's go on the whiteboard in order to solve. Y is equal to max of x1 up to xn. Let's talk about the cumulative distribution function for y that is max of x1 dot 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 xn less than equal to y. Now, if max of x1 dot 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 xn is less than equal to y, it means that each one of them individually also has to be less than equal to y. अगर maximum value y से कम है, तो each one of them less than y. So if each one of them is less than y, it can be written in this way: x1 less than y, x2 also less than y, xn also less than y. Now, each of these xi's are independently and identically distributed. So independent hai, to it can be written for each one of them less than y multiplied by x2 also less than y, xn also less than y. Now, this is basically the cumulative distribution function for x1, for x2, for xn fy to the power n is the cumulative distribution function for y. Okay, so the PDF will be basically the derivative of the CDF, n fy to the power n minus 1 multiplied by the derivative of fy, that is the PDF. So the derivative of the CDF is the PDF. Gy is this. I think this is option C. Okay. Passengers are in a queue to board a train carriage with 50 seats. Each of them hold a ticket with an assigned seat number on it. The first passenger loses a ticket and picks a random seat. Every other passenger attempts to sit in the seat assigned to them. If it is occupied, they pick a seat at random from among the seats left. What is the probability that the last passenger will sit in her assigned seat? Okay. The last passenger will sit in her assigned seat. Probabilities are 1 by 4, 1 by 3, 1 by 2, and this. Okay. So these are the probabilities or the options: 1 by 4, 1 by 3, 1 by 2, and this summation. And this is the question. Okay. Make an attempt. So ये 50 को भूल जाइए. Let's take the chance of two passenger. First passenger loses the ticket. So the first passenger chooses a seat randomly. This is the first and this is the second. So if she picks the right seat, the second person also is able to sit in the right seat. So probability that they will be sitting in their right seats is probability half. Three people, three seats. First person sits in her own assigned seat with a probability of 1 by 3. The last person will sit in their seat if the second person also sits in their seat. So out of the remaining two, the second person sits in their seat. Okay. Right. The first passenger loses a ticket and picks here, randomly chooses the correct seat. So 1 by 3. Second person will obviously sit in their own position, and the third person will obviously sit in their own position. So 1 by 3 is the probability that the last passenger will also be in the correct seat. Plus first passenger not sitting in their own seat with a probability of 2 by 3. Okay. First passenger either sitting in the second or the third seat. Supposing the first passenger sitting on the second seat. Okay. Then the second passenger will come and will have to sit in the seat of the first, because the third passenger has to be seated correctly. All right. Yeah. So 2 by 3 into this. So this gives me 1 by 3 plus 1 by 3, 2 by 3. Okay. Yes. So, sorry. What will happen here is first person in the correct seat, options for the second person is half, right? To choose the correct seat in which to sit. So 1 by 6 plus 1 by 3 is what we'll get. Sorry. And this will turn out to be 1 by 6 plus 1 by 3 is 1 by 2 again. Okay. Yes. So what is happening is first person correct seat, second person can choose any of the two seats. So picking the correct seat is 1 by 2, and the third person will obviously go in the correct seat. And this is first seat correctly. Okay. That probability that the last passenger will sit in her assigned the last passenger seat with a probability half, or someone is not sitting on the passenger seat with probability half. Why is the probability half? Because either a person is on the seat or the person is not on the seat. The probability of the two is the same, whether the person is on the seat or not on the seat. Okay.
First passenger sits in the correct seat. Sir,
Yeah.
why are we multiplying it with half then? Because when the second passenger enters,
Okay. So question number 7 was done. Now question number 8 was also an issue. Second largest number, which denotes the second largest number of the n random variables. Okay. Yes. So we need to find this out. Okay. Second largest number is what we need to find out. Let's make an attempt at that. We find out max of x1 to xn. That was fy to the power n. PDF. This is the PDF. Okay. So what we need to do here is, if there are basically three elements, what we need to do is something like this. Minimum of, if there are supposing x1, x2, and x3, then what will I do? I will do minimum of max of x1, x2, x2, x3, x1, x3. So if I find out max of x1, x2, x2, x3, and x1, x3, if supposing I have x1 less than x2 less than x3, there's only an example. This will give me what? x2, x3, x3. Now the minimum of this will be x2, which is the second highest number. Okay. So take into account with only the two case, right? So max of x1, x2, max of x1, x2 will give me an answer which will look like x1 okay. So probability of max x1, x2, so everything will be less than z1, and x1 to xn is a identically distributed, dependent and identically distributed from a continuous distribution. Okay. Okay. So this will lead to basically okay. So the PDF will be n minus 1 fz n minus 2, and I need to take into account that it's the second largest number, so it should be 1 minus fz, and the derivative of this will be fz having a negative number, so this will make it positive. Okay, so this is what it should be. I think I've made some calculation mistake somewhere. Should be Bombay. FZ. Sorry. Yeah. By mistake, I did this. It should not be n minus 1, should be n. Okay. There is a formula, there's a theorem behind this. Okay. I'll share that. 850 passengers. Okay. Next is which one? Question 10. Okay, let me share the answer. Question number 10. Six friends, none of whom share a birthday, go out to dinner and are seated around a round table. What is the probability that they sit in order of their ages? So if I arrange only five people for their age, okay, supposing this is lowest, second, third, fourth, fifth, the sixth person will automatically be put as per their age. Okay. So if I arrange five people in their age, sixth person is automatically arranged. So what is the probability of arranging five people in the order of their ages? 1 by 5 factorial. So basically 1 by 120. Basically, the number of ways in which to arrange six people around a round table is 5 factorial. Order of their ages is only one way, not multiple ways. Answer है Bombay. Let's make an attempt and see how to do this. Okay. Parameter alpha greater than 1 and xm greater than 0 is given by fx is this. So what will be the median? Median is f median should be equal to half. So 1 minus xm by the median to the power alpha is equal to half. So xm by x to the power alpha is equal to half, or xm by, sorry, this is m. M is equal to xm by half to the power alpha, right? Okay, this is my median. Now, what will be the mean? First, let's find out the PDF. PDF will be minus of minus alpha, xm to the power alpha by x to the power alpha plus 1. Okay, so this is basically alpha xm to the power alpha by x to the power alpha plus 1. Now, integration xm to infinity alpha xm to the power alpha by x to the power alpha dx. This is what I need to find out. Alpha xm to the power alpha into x to the power minus alpha plus 1 by minus alpha plus 1 goes from xm to infinity. So infinity will be basically 0 because this will go to the denominator is going to infinite, so this will be 0. So this is minus 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 plus, so alpha by alpha plus alpha minus 1, alpha by alpha minus 1, xm to the power alpha by xm to the power minus alpha plus 1. Okay, so minus this cancels out, so I am left with that. Okay, alpha minus 1, so this will get cancelled. Alpha by alpha minus 1 into xm is what I will get. Okay, right? So mean and median I need to compare. So alpha by alpha minus 1, median is 1 by 2 to the power minus alpha. So we need to understand which one will be greater, okay, because xm basically cancels out. So you can do this in multiple ways. One of the ways is just take a representative value of alpha, supposing alpha is equal to 2. Okay, so 2 by 2 minus 1 is basically 2. Okay, and this is basically 1 by 2 to the power of 1 by 2. 1 by 2 to the power of 1 by 2 is basically 1 by root 2. 1 by root 2 goes in the power, will become root 2, right? Okay, basically 1 by 2 to the power of 1 by 2 is basically 1 by root 2. 1 by root 2 goes in the numerator, becomes root 2. Now, obviously, 2 is greater than root 2. Okay. And you'll notice that when you take alpha is equal to 3, again, the same thing will happen. This will become 3 by 2. This will become cube root of 2. Okay. So this will keep getting smaller and smaller and smaller and smaller. This will keep increasing. So x bar will be greater than the median. Median is less than the mean. All right. Is this okay? Question number 15. Alice and Bob are in a close two-way political fight. Close two-way political fight का मतलब कि Alice and Bob दोनों के जीतने के chances approximately half है. A polling firm wants to poll a simple random sample of all voters to estimate the proportion who will vote for Alice. It wants this estimate to lie within a margin of plus minus 2 percentage points of the true population value with probability 0.95. How large should the sample size be to achieve this? So basically उसको क्या निकालना है, 95% confidence interval निकालना है. Okay, 95 confidence interval में the margin of error if you remember is z alpha by 2 into the standard deviation. Here the standard deviation will be basically it's the proportion, correct? Now this has to be within plus minus 2 percentage points. So this has to be less than equal to 0.02. Got it? Now for 95%, this is 1.96. 1.96. This is basically half into half because it's a very fierce political fight. This is my n, which is less than equal to 0.02. Please try to find out what value of n will I get here. Basically 1.96 into half divided by 0.02 is less than equal to root n. So what will this be? 1.96 into half divided by 0.02, 49. Now 49 square is how much? 2401. So 2401 less than equal to n is what I will get from here. So for example, ठीक है, how large should the sample size be? At least 2401 is my answer. Is this okay? Is this understandable? समझ में आ रहा है? कॉन्फिडेंस इंटरवल अगर आपने अच्छे से नहीं किया है समझ में नहीं आएगा. टेस्टिंग ऑफ हाइपोथेसिस अगर आपने अच्छे से नहीं किया है समझ में नहीं आएगा. Ashoka University Sample 2.2, question number 13. H is heads and T is tails. The outcome of tossing a coin. Probability getting a head P, getting a tail 1 minus P. Call the coin fair if P is equal to half and unfair otherwise. Toss the coin 3 times independently. Consider the events A, at most one tail, that is this, and B, all tosses are the same, A and B. Which of the following is true? So, what is the probability of getting an A? All head is basically P cube. Head, head, tail, head, tail, head, 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 tail, head, head, tail is basically P into P into 1 minus P. So basically what we'll get is 3 into P square into 1 minus P. So what is this? P cube plus 3P square minus 3P cube. So 3P square minus 2P cube. This is the probability of A. Probability of B is equal to all head or all tail, all head or all tail. Okay. Now, which of the following statement? A and B independent. Probability A intersection B is basically probability of getting head, head, head. What is common between the two? Head, head, head. Head, head, head is basically P cube. So when is P cube equal to 2P cube into 3P square minus 2P cube? Okay. So basically, what do we have? P cube common. This becomes 6P square minus 4P cube. So basically 6P square minus 4P cube is equal to 1. This is what we get. So 6P square is equal to 1 plus. Okay. Right. So when will this happen? That all tails. Okay. So P cube is equal to this multiplied by this. Now you'll notice that when P is equal to half, what will be PA? PA will be 3 by 4 minus 2 by 8. That is half. Probability of B will be basically 1 by 8 plus 1 by 8, which is equal to 1 by 4. Okay. For P is equal to half. Now head will be basically 1 by 8. So probability A intersection B is equal to PA into PB when P is equal to half. For other values of P, just put the other values of P, take any value, 1 by 3, 2 by 3, whatever you want to put. You'll see that A intersection B is not equal to PA into PB. Okay. PA intersection B is not equal to PA into PB. Okay. So either may A and B will be independent only if the coin is fair. Okay, now let's take a look at question number 9. A and B play a game with two six-sided dice. Each dice has some red faces. The last question for today, and after this, we'll finish the session. I wish each of you all the best for your Ashoka preparation. And some blue faces. The two dice are thrown simultaneously. If the top of each dice is the same color, A wins. And if they are different colors, then B wins. One dice has 5 red faces and 1 blue face. So first dice, supposing 5 red and 1 blue face. How many red faces does the other dice have? Let X red faces and 6 minus X blue faces. How many red faces does the other dice have if both the players have the same chance of winning? So probability that A will win is both dice have same color. Both dice have same color. Supposing both dice have red, probability 5 by 6 into X by 6. Or both have blue, 1 by 6 into 6 minus X by 6 is the same as probability of different colors. Different will be basically red, blue, and blue, red. Red, blue, or blue, red. Okay, so this is what I have. So this is basically 5x by 36 plus 6 minus x by 6. 6 by 36 minus x by 36 is equal to 30 by 36 by 36 plus x by 36. Okay, so this is basically 1 by 6, this is 5 by 6. 5 by 6 minus 1 by 6 is 4 by 6. 4x by 36 plus 4x, 8x by 36 is equal to 24 by 36. X is equal to 3. That means the number of red dice that is there in the second is 3. Right, so that is what we have. So we'll finish here for today. Unfortunately, because of paucity of time, this is what we have time for. I wish each of you all the best in your Ashoka preparation and happy studying. You have a couple of days, finish the syllabus by tomorrow and rest on Saturday. Extremely important for you to have a fresh mind when you attempt the paper. Okay. Thank you so much, everyone, for being a part of the session for today. And I hope that this has helped each